So, lesson 3.1, this is what I'd like you guys to do here. Read it, and I would like you to draw from the definition of diameter to the picture of where diameter is. So you make that connection of like, that's the definition, that's what it means, and there is a picture of it. So I can go from the picture to it if I want. So here, I go diameter, goes through the midpoint. It connects on one side of the circle, goes through the midpoint, and stops on the other side in a line segment. That line segment is straight. That's what line segments are. And then radius. Go from here to there. It is from the outside of the circle to the midpoint. And then the last one, circumference. Circumference is the perimeter around a circular object, some sort of cylinder. Okay, that is circumference. Perimeter is used to describe around a different geometric shape, like a polygon. Perimeter, though, in the sense of a circle, we use the word circumference, and there's a specific reason why. So, when we're talking now about circles, there's this thing called pi. You guys have probably seen the symbol. Pi is a... 3.14. Yes, it's a value. It's a value that works in congruence with circles when finding the circumference and when finding the area. Now, how it was found is really cool. And I'm going to show you how it was found. But the value of it rounded is 3.14. Now, pi goes on for infinity. It never, ever, ever ends.
And it never repeats the same.
And it never repeats the same sequence. So, it goes on forever, which is really, really cool.
Didn't they get that by rocking the diameter around the circle?
Yeah. So, pi was discovered because a mathematician, a Greek mathematician way back in the day, or it might have been Roman actually, found out that when you take the circumference of something, the measurement around, and you divide it by the diameter, you're always left with this number pi. It's a ratio, and the ratio is circumference divided by diameter equals pi.
Was it named pi until they named it after?
You know what? I took that math history course. I can't remember. You might be right. That'd be so cool.
Dude,
I don't know if you are.
If my name was Pi.
I would like. Come on. So I want to show you what this. I want to show you what this leads to, and you're going to want to take notes. So here, under the first definition, where it has circumference divided by diameter equals pi, I would like you to write it this way.
Where are we writing this?
Well, underneath the equation, the first equation on the bottom of your page. Right here. Write it right there. So, circumference divided by diameter equals pi. Diameter is the length across. Whenever I do this, I'm going to be left with pi. We're going to do a little activity today where you're going to kind of explore and see if that's always true. This is what's cool about this equation. It has an equality. Now, what does an equality allow me to do? John!
If you have a ruler like that, if whatever you do on that side, you do on that, the other side.
So whatever I do over here, I can do over there, and it makes it still balanced. So, let's say if I wanted to isolate circumference. Okay, I wanted to know just the circumference. Well, in this equation, I'm finding pi. So if I want to know just circumference, I need to get rid of diameter over here. So how would I get rid of diameter? I would multiply, because here it's being divided by, I multiply by diameter. Because diameter times circumference divided by diameter, it's basically these two cancel out. But if I multiply by diameter here, what do I have to do over here?
Do it the same.
I got to multiply by diameter over here. So that's how I get the second equation here, which is circumference equals pi times diameter. So if I know the diameter, I can always find the circumference because pi is 3.14, right? So I can just take 3.14, multiply it by diameter, and I get the circumference. Which, think about it. You got these, objects that are really, really big. Maybe it's an expo or something. It's going to take a lot longer to walk and measure around it as opposed to go right through the middle. If I go through the middle, I go from one and the other, multiply by 3, I know now how long it is around as well. So the last one, so now I have this relationship. Again, I have an equality. Whatever I do to one side, do the other. So I have this equality, but now I'm like, I don't want to isolate circumference. I want to isolate diameter. So if I want to isolate diameter, that means I've got to get rid of pi. Pi is being multiplied here, so what would I do to get rid of it? Divide by pi. Divide by pi. Divide by pi. These cancel out. So the last relationship that you find is that diameter equals circumference divided by pi. So, and that can be useful in like circular aquariums where it's a lot harder to measure through the water, or if you have a solid object, it's hard to measure through it, but you can measure around it. So now I measure around it, and I can divide it by pi, and now I know the distance through it. It's useful in, do you know, what are they called? Those agricultural, what are they called? No. Yeah, crop circles.
Hey.
Bam, thank you, John B.
You're welcome.
So, crop circles are caused by irrigation, right? Well, when you're growing crops, if you're growing a lot of crops, it's hard to measure through it, but you can measure around it. So this kind of math gets used a lot in agriculture, especially when you have those circular irrigation systems that operate in a circle. You just walk it, and you have like a little measuring thing.